My name is Alfina Damayanti. First, we will tell about the linear equation of one variable. Task 1, English Mathematics. Hi ma'am, what is a linear equation of one variable? Hi John, if you want to know about the linear equation of one variable, check this out. The definition. A linear equation in one variable, an equation which has a maximum of one variable of order 1. It is of the form ax plus b equals o, where x is the variable. This equation has only one solution. Few examples are 3x equals 1, 22x minus 1 equals 0, 4x plus 9 equals minus 11. The standard form of linear equation in one variable is represented as ax plus b equals o, where a and b are real numbers and a is not equal to 0. This is the formula of linear equation in one variable is ax plus b equals o. Algebraic equation. Expressions that involve variables inequality are called algebraic equation. These expressions are formed by two equations involving expression on left and right with a equality sign in between the two. The expression on the left is called left-hand side or alleges, and the expression of the right is the right-hand side expression or arages. Generally, in an equation, the values of alleges expression is equals to the arages expression, and these values are called their solution. To obtain the solution of an equation, we use the various arithmetical operations on the two sides so that the balance between the equations are not disturbed. In this part, we begin by classifying linear equation in one variable as one of three types: identity, conditional, and inconsistent. An identity equation is true for all values of the variable. Here is an example of an identity equation. 3x equals 2x plus x. So, the solution set consists of all values that make the equation true. For this equation, the solution set is all real numbers because any real number substituted for x will make the equation. A conditional equation. Conditional equation is true for only some values of the variable. For example, if we are to solve the equation 5x plus 2 equals 3x minus 6, we have the following. 5x plus 2 equals 3x minus 6. Then 2x equals minus 8x. Then equals to minus 4. The solution set consists of one number is minus 4. It is the only solution and therefore we have solved a conditional equation. Third, an inconsistent equation. Inconsistent equation result in a false statement. For example, if we are to solve 5x minus 15 equals 5 quantity x minus 4, we have the following. 5x minus 15 equals 5x minus 20. Then 5x minus 15 minus 5x equals 5x minus 20 minus 5x. Subtract 5x from both sides. And then minus 15 not equals to minus 20. This is a false statement. Indeed, minus 15 not equal to minus 20. There is no solution because this is an inconsistent equation. In this part is solving linear equation in one variable. Type 1. Variable on one side and number on the other side. For example, 4x plus 5 equal to 9. Balancing method. 4x plus 5 equal to 9. Write the equation. And then 4x plus 5 minus 5 equal to 9 minus 5. Subtracting 5 on both sides, hence not disturbing the balance. 4x equal to 4, simplifying. And then 4x divided by 4 equal to 4 divided by 4. Dividing by 4 on both sides, hence not disturbing the balance. And then x equal to 1, simplifying. B. Transposing method. In this method, the numbers are moved from one side of equality to other sides by changing the sign. The changes are as follows: plus change to minus, minus change to plus, times change to divided by, and divided by change to times. For example, 4x plus 5 equal to 9, taking 5 for erases. 4x equal to 9 minus 5, for x equal to 4, taking 4 to erases. X equal to 4 divided by 4, and then x equal to 1. Type 2. Variables and numbers of both sides. For example, 2x minus 3 equals x plus 2. A. These types of equation can be solved by either of the two methods mentioned earlier. B. The rules of transposing numbers are also applicable for variables. For example, 2x minus 3 equal to x plus 2. Taking 3 to erases, 2x equal to x plus 2 plus 3. 2x equal to x plus 5. And then taking x to erases, 2x minus x equal to 5. X equal to 5. Last part is application of linear equation. Linear equation in one variable can be used to calculate the value of an integer when we are given two or more integers with one of them being unknown. Using the expression in an equation form, we can easily find the value of an unknown integer. And then linear equation help us deduce integers in many word problems of arithmetic. Only this expression make the equation simple to understand, but also help in reaching to conclusion easily and fast. On the task 2, English Mathematics. In this part, we will tell about square base pyramid. This lesson provides an informative overview of the properties of square-based pyramid. Along with providing the definition for a square-based pyramid, the lesson includes the formula for finding base area, volume, and surface area. Table of contents of this part is: first, example in the word of square-based pyramid, and second, definition and properties of square-based pyramid, and third, formula for square-based pyramid. First, example of square-based pyramid. You need to travel to Egypt to know that it hosts some of the world's most marvelous wonders, the Pyramid of Giza. These pyramids were built between 2589 and 2504 BC, so it is a true wonder that they still stand strong and tall today in the expansive desert just outside of Cairo. The pyramids of Giza are one of the oldest examples of square pyramids. Second, definition and properties of a square-based pyramid. Like all pyramids, square pyramids share the property of being a polyhedron with a polygonal base and triangular sides, reaching up toward a point called an apex. A polygon is flat, enclosed plane shape with less three sides and angles. From this information, it can be concluded that not all pyramids are square pyramids. All pyramids are named after their base. So, a square pyramid is a pyramid with a square base and 4 triangle sides, 5 vertices, and 8 edges. The base of this pyramid is square and the top point is the apex. It was mentioned that a square pyramid is a polyhedron, but to be more specific, it could be called a pentahedron because it is a polyhedron that has 5 sides. Third, formula of square-based pyramid. There are formulas for calculating the base area, volume, and surface area of the square pyramids. First, study that picture and look closely at how each dimension is labeled. The dimension of a square pyramid as follows. A is base side length, E lateral side length, H height, and S slant height. Surface area. Formula of surface area square-based pyramid. Surface area equals quantity square base area plus 1 divided by 2 times perimeter times slant length. Square base area is A times A, and the perimeter is A plus A plus A plus A equals to 4 times A. Example of surface area square-based pyramid. Side faces are the same, slant length is 3, base is square with side length of 5. Slant length is 3 and A is side length of 5. Answer. Surface area equals to square base area plus 1 divided by 2 times perimeter times slant length equal to 5 times 5 plus 1 divided by 2 times 5 plus 5 plus 5 plus 5 times 3 equal to 25 plus 1 divided by 2 times 20 times 3 equal to 25 plus 30 equals to 55. And the next, volume of square base pyramid. Volume of square base pyramid equals to 1 divided by 3 times square base area times height. This is h is height and square base area equal to a times a. This is an example of volume square base pyramid. Base is square with side length of 5 and height 6. This is h is 6 and a is side length is 5. Volume equal to 1 divided by 3 times square base area times height equal to 1 divided by 3 times 5 times 5 times 6 equal to 1 divided by 3 times 150, so equal to 50. 50 is volume of this square base pyramid. Thank you for this part, and we will next in task 3. In this part is task 3 English Mathematics. In this part, we'll tell the statistics. Let's check this out. Table of contents in this part. First, data statistics. And second, table of data statistics. Third, pie chart of data statistic. And fourth, bar chart of data statistic. First, what is a statistic? Statistic is the discipline that concerns the collection, organization, analysis, interpretation, and presentation of data. How to display the statistical data? There are several ways presenting data, including with frequency table, bar chart, line chart, pie chart, and etc. Here, I have provided a data. This data we will use to understand the use of data tables, pie chart, and bar chart. In Mia class at XYZ High School, a counseling teacher conducted a survey of the mathematics and natural science subjects most liked by students. The survey results show that out of 15 students, Bendy, Zafran, and Ali like physics lesson. Rio and Fabi love math. Alfi, Ibnu, Fira, and Hadi like chemistry. Finda, Arif, and Danny also like mathematics. The other students like biology lesson. For convenience, we write separately whoever likes each subject. Mathematics, they are Rio, Fabi, Finda, Arif, Danny. Physics, they are Bendy, Zafran, and Ali. Biology, Alfi, Ibnu, Fira. And chemistry, 4 other students. So, 5 students for mathematics, 3 students for physics, 3 students for biology, and 4 students for chemistry. Second, data table of statistics. Data tables help you keep information organized. If you are collecting data from an experiment or scientific research, saving it in a data table will make it easier to look up later. And then, data tables can also help you make graphs, and other charts based on your information. How construct data table? There are procedures to construct data table. First, name your table. In our data, so we name our table is Table 1, students who like subjects math and science. In name your table, write a title at the top. Make sure the title relates to the data you will put in your table. Second, figure out how many columns and rows you need. In our data, so we need 6 rows and 3 columns. And then draw the table. Make the necessary number of columns and rows. Don't forget to leave the top row blank. This is where you will label your columns. 4. Label all your columns. First column is we label number in the first row. Number is optional, but the leftmost column should be reserved. For example, in this research, how much students like listen mathematics, physics, biology, and chemistry. So the independent variable will be subjects. The subjects is independent variable. And then the next column will be labeled frequency. The last row, this is a label total frequency. Total frequency is optional label. 5th, record the data from your experiment or research in the appropriate columns. And then check your table. Look over your work to make sure everything is correct and clear. In our research, we know that mathematics have 5 students like it. Physics have 3 students like it. Biology have 3 students like it. And chemistry have 4 students like it. So total frequency is 15. And third, we will tell about pie chart. A pie chart displays data, information, and statistics in an easy-to-read pie slice format with varying slice sizes telling you how much of one data element exists. The bigger the slice, the more of the particular data was gathered. How construct pie chart? Procedure to construct pie chart. First, work out the total number of students. In our research, we have 15 students. Second, to calculate the angle of each segment, work out the fraction of the total that got each grade 316 degree. To calculate the percentage of each segment, work out the fraction of the total that got each grade 100%. For example, subjects mathematics. In subjects mathematics, we have 5 frequency. We have frequency is 5. To calculate the angle is 5 divided by 15. 15 is total frequency times 316 degree equals to 120 degree. 120 degree is angle of mathematics. To calculate percentage is 5 divided by 15 times 100% equal 13.3%. So 13% is the percentage of mathematics. You repeat this step for physics, biology, and chemistry. Last step. Once you have calculated the angles and percent of the segment, construct the pie chart. This is the construct of our pie chart. We can read this pie chart. For pie chart students who like math and science, I can easily see that physics and biology, the smallest number of students like both. That's not to say that physics and biology is difficult subjects to studying, but the data show that mathematics preferred, followed by chemistry, then physics and biology. Fourth, bar chart. In the last lesson, we learned that a bar chart is used to represent data visually using bars of different height or length. Data is graphed either horizontally or vertically, allowing viewers to compare different values and draw conclusions quickly and easily. And then, a typical bar graph will have a label, axis, scales, and bars, which represent measurable values such as amounts or percentages. Bar graphs are used to display all kinds of data, from quarterly sales and job growth to seasonal rainfall and crop yields. Bar graphs have a labeled x-axis, horizontally axis, and y-axis, vertically axis. When experimental data is graphed, the independent variable is graphed on the x-axis, while the dependent variable is graphed on the y-axis. Did you know, friend? There are three types of bar chart: stacked, single bar chart, group bar chart, and stacked bar chart. How construct bar chart? There are 5 steps to construct bar chart. First, find the rank in values. To find the rank in values, we can have a question: what units are used, what is the greatest value, and what is the least value. The units are frequency or number of students. The greatest value is 5 and the least value is 3. Determine a scale. Second is determine a scale. Using a Cartesian coordinates, the y-axis of the scale must start at 0. In this data, type 1, so the vertical scale will rank from 0 to 6. This picture is to vertical or y-axis is rank from 0 to 6. And type 2, so the horizontal scale will rank from 0 to 6. This is the horizontal scale or x-axis from 0 to 6. One usually we call column chart, and type 2 usually we call bar chart. Label the graph. Label the marks by the units they represented. We can represent that. First, this is for math, and then this is for physics, and then this is for biology, and this is for chemistry. Also, in type 2, this is for math, this is for physics, this is for biology, and this is for chemistry. Fourth, draw the bars. So, to draw a horizontal or vertical bars that represents number of students. Example, thus the bar for mathematics is until 5. Example, first, to mathematics is 5. And then physics, 3. And then biology, 3 students. And chemistry, 4 students. And then type 2, math is 5, physics are 3 represented, biology 3, and chemistry 4. Give a graph a title. What is your graph about? In type 1, a horizontal axis is subjects and vertical axis is number of students. This data, the title of this data is Student Who Like Subjects Math and Science. And type 2, a horizontal axis is number of students and vertical axis is subjects. This data, the title of this data is Students Who Like Subjects Math and Science. The easiest way to create a bar graph is to use the charts tool in Microsoft PowerPoint and Microsoft Excel. First step, we choose an insert and then click charts tool, and then we can choose column or bar. Here we choose a column. This is cluster column, and then click OK. After we click OK, we will go to Microsoft Excel to editing our data. First is the label of first column and third column, subject and number of students. And then first data is math, number of data 5, and then physics 3, biology 3, and chemistry 4. After that, we can click this X. After we click X and we have done that this data is clear, so we will show this bar chart. Data Students Who Like Subject Math and Science is the title of this bar chart. Color pink is represented the frequency of how many students like the subjects. We can read this data. The subjects mathematics have 5 students who like it, and then physics 3 students who like it, biology 3 students who like it, and chemistry 4 students who like it. Minimum data and maximum data. Minimum data. This number is the data value that is less than or equal to all other values in our set of data. Data above is who students like math and science data. There is no minimum data because the independent variable is not value. So there is not a minimum data. And then maximum data. This is number is data value that is greater than or equal to all other values in our set of data. In the XYZ class and Students who like math and science data, there is not a maximum data because the independent variable is not values, so there is not a maximum data. That brings us to the end of my presentation. I fully realize that it is not flawless. There is still probably a lot of questions. Feel free to speak out and we can have discussion to work out for the best solution. Thank you for your listening to my presentation. I hope what I have said will be beneficial for all of us. Wassalamualaikum warahmatullahi wabarakatuh.